If you have clicked this video, then you, just like me, have a keen interest in improving your sports strategy. Throughout this video, we're going to utilize basic statistics such as conditional probability and expected value to give you the tools to make smarter decisions in a host of applications, including sport. I'm extremely enthusiastic about this area of mathematics, combining my love for both statistics and sports. I hope to share this passion with you guys, and hopefully we all learn something along the way. Let's start with a golf example shown on the screen now. This is the 9th hole of one of my favourite and one of the all-time greatest golf courses, Wedge Island from Wii Sports Resort. It's a par 5, meaning that for regulation golf, to get a par, you're expected to reach the green in just 3 shots. Let's, for example, say our first shot, our drive, takes us to this position here, with 200 yards to carry the water and onto the green, or 140 yards to go short of the water for an easy 60-yard shot onto the green. What is the best decision to minimise the number of shots we take? Let's also consider this football example, although it can also be applied to other team sports. We have the ball on the left wing, with a striker making a run through the middle. Should we go for the killer pass to the striker, go for a slightly simpler pass to the midfield, or even go back to the defender and recycle possession? I want you to keep these decisions that you made for both the golf and the football example in your head as we move through this video. We'll cycle back to this at the end, and I'll explain how you can make the best decision for you. Here, we're going to introduce some basic notation. This fancy looking P means probability of, whereby inside the brackets is the probability that we're measuring. Therefore, the probability of success can be written as such. In the situations we're going to consider, we either have success or failure. We'll give examples of these in a sec. The probability of success can therefore be written as 1 minus the probability of the failure. And this can also be written as P equals 1 minus Q. An example of this, to help you solidify your knowledge, is estimating a probability of completing a pass is 0.8. And we can therefore say that the probability of an incomplete pass would be 1 minus 0.8, which equals 0.2, just by subbing into the equation we discussed before. We can also take an example in golf, whereby we have the probability of making a 30-foot putt being estimated to be 0.4. And therefore we can say the probability of not making the putt would be 1 minus 0.4, which equals 0.6. This is commonly known as the Bernoulli distribution, and although not discussed in too much detail in this video, I'll leave a video down below that will tell you all about it if you're interested. Using the notation we just introduced, we're now going to discuss conditional probability. This is the probability that an event occurs given we know another event has already occurred. This can be written as such, reading the probability of event B given event A has already occurred. This left-hand side is what we're measuring given the conditional event on the right-hand side has already happened. This can be written as the probability of event A and event B occurring, divided by the probability of event A. This can be rearranged to find the probability of event A and B, or vice versa, depending on what we know. Let's take this example in golf, whereby we have the probability of a successful approach, the shot onto the green, is 0.2, and we have the probability of a successful putt, given a successful approach, is 0.5. We can therefore say the probability of a classic up and down in golf, whereby we have 1 approach shot and 1 putt, is 0.2 times 0.5, which equals 0.1. Using what we've discussed so far, let's now move on to expected value, or EV. This is the long-term value for any decision made, removing any short-term variance that could occur. The formula for this is the probability of success times the reward for any success, plus the probability of failure times the penalty for any failure. Let's look into this using the golf example that we started with. We have a 200-yard carry shot over the water and onto the green, or we can lay up for just 140 yards, short of the water, and therefore much safer. For simplicity, let's assume the probability of success of laying up is 1 or 100%. We'll say the probability of success for going for the green is 0.3. And the penalty for failure is going in the water and therefore incurring an additional stroke. Let's investigate the expected value using the following table, We have a column for the decision, one for the probability of success, which we can therefore use to calculate the probability of failure, the reward, the penalty, and finally the expected value. So let's start by filling in this first row. We have the decision as going for the green. We have the probability of success as an estimated 0.3. We have the reward as -1 shots. We have the penalty as an additional penalty shot. And we have, therefore, the expected value of 0.3 times -1 plus 0.7 times 1, which we can show is 0.4 additional shots. If we were to fill out this second row, we can show that the expected value is 0, as we might expect. However, let's now consider if we're much better at golf, and therefore we have the probability of success as an estimated 0.6. Filling out the row in a similar fashion, we have the expected value of 0.6 times -1 plus 0.4 times 1, which we can show is -0.2 shots, and therefore the more optimal strategy in this situation. If you're interested, have a pause and play around with these numbers and see what decisions you'd make in any given circumstance. Let's now move on to the example that we started with in football, although it can be easily applied to other team sports as well. We're going to, for simplicity, assume that the value of keeping the ball, or maintaining possession, is 0.02 expected goals, and thus is the penalty for losing the ball also. Using the same table as we used for the golf example, let's start with the first decision as going for that killer pass. We're going to estimate the probability of success as 0.1, and the reward for this pass to be 0.2 expected goals. As discussed, the penalty would be -0.02 expected goals, and therefore the expected value for this decision can be calculated as such. The second decision is to go for the safer pass, which we're going to have an estimated probability of success of 0.9. The reward for maintaining possession through this safer pass is 0.02 expected goals as discussed, and therefore the penalty is -0.02 expected goals. The expected value can be calculated as such. In this example, it's clear to see that the expected goals is much higher for the decision of going for the safer pass compared to the killer pass, and therefore the better option would be to play it safe and maintain possession. From this, we can expect to find better chances and therefore find better opportunities to scoring. However, there is no perfect solution. In any given circumstance, it's very difficult to predict the true value of the probability of success. For this, what we often do is we take previous attempts. For example, if we're able to make that killer pass 20 times out of 100, or go for that long shot over the water 20 times out of 100, we can say that our estimated probability of success is 0.2. However, we can say that there's so many different variables that come into each decision. For example, we may be on an absolute hot streak of form, and therefore we may feel great about going for that more difficult shot. In contrast, we may be able to say we're very nervous, and therefore going for that shot is just a terrible idea, as we may be underperforming what we normally do. These are all factors to consider, as well as the fact that if the conditions are bad, we may have lowest probability of success, and vice versa for better conditions. In golf, it's easier to go for that long shot if the weather's really sunny compared to whether it's wet and windy. It's also important to consider the context that you're in. In competitions, you're often trying to win, and therefore, sometimes the long-term best decision with the best expected value isn't always the best play. In golf, you may be targeting a score of 5 under in order to win a competition, and therefore, on the final hole, you're not going to lay up, even though it may be the decision with the highest expected value. And instead, you're going to go for the green and go for the win. In football, this may be being 1-0 behind in the dying embers of a game, and therefore we may need to take risks in order to create chances. These are also things to consider when coming to the best decision for any given circumstance. If you enjoyed this video, then please leave a like and any comments or feedback you may have down below. I'll leave a feedback form with a short questionnaire, and I'd really appreciate it for anyone that can fill that in. Thank you, and good luck in all your sporting decisions going forward.